Hello, my name is David Bray and I'm an applications engineer at National Instruments in the United Kingdom. Today I'm going to be talking you through a tutorial that I've created on strain-based measurements and how we can use the myDAQ to take such measurements. The hardware that I've used for my tutorial is an myDAQ, which is connected up to an Elenco myProto board for the wiring of the circuits that we'll be configuring. And also I have a strain gauge that's mounted to my test specimen, which in my case is just a plastic beam. As we go through the early parts of the tutorial, we get a background on strain gauges and WheatstoneBridge circuits, and we then move on to one of the more basic WheatstoneBridge circuits, which is known as the quarter bridge circuit. After talking through the various theory on this, we have a practical example where we can test the circuit that we've built and see that as a compressive force is applied, we will see a negative strain measurement, and as a force that creates extension is applied, we will see a positive strain measurement on our graph. Then moving on, we talk about some slightly more complicated circuits, such as in particular the half bridge strain gauge circuit and the full bridge strain gauge circuit. And in both cases, we will be providing the necessary calculations that you need to convert the voltage that you'll be reading with your myDAQ into a strain. We then go on to talk about the various errors that we can expect when taking strain-based measurements, such as offset error and gain error. In the case of offset error, we provide an example in which you'll see here the graph has no strain applied to it, but is still receiving a value of 0.004 strains. And in this case, this would mean that it's assuming that this is 0. So what we want to do here is to effectively zero our reading. So by clicking the null calibrate button, you'll find that in the software this reading has been zeroed, and we can now take strain-based measurements as we wish and get the values, get more accurate values. Moving on, we provide an example with gain errors, which, as you can see on this graph, although taking a reading starting at 0, you'll see the green line maybe represents a strain that's slightly more than we would normally expect, and the red line is what we would expect to receive when these forces are applied. We then have a circuit shown, which is how you would go about correcting this error using what is known as a shunt resistor to provide you with an expected value. Okay, I hope you found this video interesting, and if this is an application that's maybe of interest to you or of use to you, then please go ahead and download the LabVIEW tutorial and work your way through it in your own time. Thank you.